showing my screen.
We see
Can
your
you see
screen.
it?
Yes.
Oh, okay. And try to size it so that everybody can see it, even more people using notebooks. So I'm talking about Ivan Feinstein's paper that is actually 4 years older. Came 4 years after Cohen's paper, and where he tried to do something that actually is pretty close to my heart, and that is to avoid these religious fights within supposedly scientific field, which I think whenever we have religious fights, it just means we're not really understanding what we're talking about. So I would also start with somebody who reversed his position, and that was Fisher, who in his later life actually became much more friendly towards statistical testing and closer to Nyman Pearson, whom he had been fighting with for quite some time. But in 1956, he said, no scientific worker has a fixed level of significance at which in all circumstances he rejects hypotheses. He rather gives his mind to each particular case in light of his evidence and his ideas. And so the choice of a fixed alpha for hypothesis testing, or for confidence intervals for that matter, it may be questionable. We may actually need to adjust that to the purpose of what we are actually, to whatever decision we have to make. And to help that, Birnbaum in 1961 came up with something that's called a confidence curve that gives the confidence level for all, or the confidence intervals for all interesting levels. And here I have a small Excel spreadsheet. We can say if we have 25 experiments, if we have only 2 that are positive, or we have 5 that are positive, or 15, or 17. Oops, a mistake here. 17 or 20. Then we see the different shape of this and asymmetric shape of this curve showing the range of the different confidence intervals. So I think if we would actually use Birnbaum's idea and present all these intervals, we probably wouldn't have a discussion because whether to use p-values or confidence intervals, because then we would have the best of both worlds. Anyway, so the problem is that editors often say, well, there's a tendency to say we just give confidence intervals, which is, you can construct at least approximately a confidence interval from the estimate and the standard error. But doing it the other way around, for the reasons that we have seen before, actually is more complicated. So presenting a p-value, the estimate, and the standard error is something that probably might be even preferable to presenting confidence intervals, because it gets closer to the idea to give people the options to extract the information that they need to make their decisions. Another point was that if the test result yields a non-significant result, the upper border of the confidence interval will show how large D0 might have been, in particular when compared to the difference delta deemed important. That's what Feinstein says. So as I read this now so if we choose a lower alpha, then we get a wider confidence interval. And that means that the delta might have been larger. That shows that even people who are very in favor of confidence intervals often misinterpret them as much as p-values are being misinterpreted. Another defect that Feinstein addresses is another descriptive boundary value that has received even less attention than delta is zeta, the upper magnitude of a trivial value. So it's over here. And the quantitative boundaries alpha naught and zeta cannot be rigidly fixed because they will vary in diverse situations according to the biological implications and the population impact. So here he agrees wholeheartedly with the later statement by Fisher that alpha should not be fixed because it depends on the consequences of type 1 and type 2 errors and other considerations. So we have two areas. We have, on the one end, we have issues like the null hypothesis and the power that affect the design issue. And then we have, when somebody is reading the paper and actually trying to base a decision on it, the person needs to fix zeta and then also the alpha zeta to make sure that the decision to be made is appropriate for the situation. Because that is something that I think in the discussion gets often overlooked, that eventually people are to have to make decisions. They have to decide whether to do a new experiment, whether to believe it, whether to do something else. And as we know from Nyman-Pearson, then using the significance test approach with the correct interpretation, of course, is overall the strategy that leads us to the best results in summary. Okay, so when we are communicating information on the side of the author, there should be a sample size calculation presented, a p-value, and the estimate as well as the standard error. Or as a replacement for that, although it won't be as useful in many situations, confidence interval, because if we are presenting the confidence interval, it is exact for that particular level only, and it is pretty difficult for the normal reader to say, well, if I would like to have a different level of alpha, what would that confidence interval be? Okay, so the reader then needs to assess the level alpha zeta, as Fisher stated, and the minimum effect size zeta, and then we have the reader can make as much use of the paper possible based on the complete information, or it would be even better if the complete information would be given, and these are the confidence interval stating which hypothesis could be rejected given the data at a particular level and which hypothesis could not be rejected. So that is what I read from this paper, showing in a sense p-values and confidence intervals are, as he states, two sides of the same coin. You can make the same errors in interpreting both, and each of them has its relative merits and deserves to be published. So that is my interpretation of Feinstein's paper.
Thanks, Knut, and in the discussion we'll talk about what you think about these papers.